Welcome back students to the part 2 from the chapter Magnetism and Matter. In this module, we'll be discussing about the dipole in a uniform magnetic field. Considering a dipole, we know the torque produced by a dipole kept in a uniform magnetic field B is given by tau is equivalent to m cross B, which is minus mb sin theta, where tau is the restoring torque, B is the external magnetic field, and theta is the angle between magnetic moment M and magnetic field B. The negative sign is given to represent the restoring torque, which is opposite to the deflected torque. By Newton's second law, we know restoring torque is equivalent to I alpha, where alpha is the angular acceleration. Replacing alpha by d omega by dt, where omega is the angular frequency, and again replacing omega by d theta by dt, where theta is the angular displacement, we get restoring torque is equivalent to I into d square theta by dt square. Equating the two restoring torques, we get minus mb sin theta is equivalent to I into d square theta by dt square. For small values of theta, sin theta will be approximately equivalent to theta. Hence, minus mb into theta is equivalent to I into d square theta by dt square. Rearranging the equation, we get d square theta by dt square is equivalent to minus mb by I into theta. Here, I is the moment of inertia. The above equation resembles the equation for simple harmonic motion of the form d square x by dt square is equivalent to minus omega square x. Comparing the value of omega square from both the equations, we get omega square is equivalent to mb by I, or omega is equivalent to square root of mb by I. Time period t is given by 2 pi by omega. So 2 pi divided by square root of mb by I, which is equivalent to 2 pi into square root of I by mb. So a dipole in a region of uniform magnetic field is having an angular velocity of omega is equivalent to square root of mb by I. Hence, B is equivalent to omega square I by m. And also we have seen time period t is equivalent to 2 pi divided by square root of mb by I. From the above equation, for B, substituting omega is equivalent to 2 pi by t, we get B is equivalent to 4 pi square I divided by mt square. Now that the dipole is kept in a region of uniform magnetic field, and since it is rotating, it tends to have a potential energy. So, the potential energy of a magnetic dipole in a region of magnetic field is given by U is equivalent to minus mb cos theta or minus m dot b. Here, theta is the angle between magnetic moment M and magnetic field B. Hence, the work done in rotating the dipole in a uniform magnetic field from angle theta 1 to theta 2 is given by mb into cos theta 1 minus cos theta 2. Hope you have understood about the potential energy of a dipole, and the time period and angular velocity of a dipole when it is kept in a region of uniform magnetic field. Thank you, dear students.